We all should have covered some maps and plans at the beginning of the year. So some of this will be revision. All right. So please don't throw stones at me if move a little bit faster in the topic, because we should have covered this in term 1. All right. But I'm going to revise some of the things tonight again. Okay. So I don't know if you can see that, but you can right click on the teacher's video feed and uncheck the pin option. All right, right click on the teacher's feed and uncheck the pin option. All right, so we're going to do some basic calculations with this map. Now, it's difficult to teach this online because you should have a map in front of you. You should be measuring and working with and on your map. So it's a bit difficult, but I've got a ruler here to work with, and we're going to try and use this map, and I'm going to try use the ruler to show you exactly what you need to do. We'll see how it goes. Okay, so we have a map here, and it looks like it's somewhere in the Western Cape. Okay, maybe scroll up a little bit. There we go. We see a harbor there, somewhere in the Western Cape. All right, at the top we see a scale. Can anyone in chat or someone tell me what type of scale do we see at the top? Top left. Put it in chat if you know. It looks like a harbor here. Some touristy places marked with stars. We've got car parks marked with a car. And there's some labels there as well. All right, good. Yes. Good. Bar scale. Yes. Ah, Safiso. I remember you asked about that. Yeah, I can't remember what we suggested to Safiso. We can contact the WhatsApp group, or we need to give the WhatsApp group his details and then see what they can do. All right, so there's information on the map about different tourist places. It's Victoria and Alfred waterfront. So this looks like Cape Town. It looks like Cape Town to me, but we don't have information whether it is Cape Town. And yes, that scale on the top there is a bar scale. Sometimes it's called a linear scale, a line scale. But yes, bar scale is absolutely correct. And then down here at the bottom, I need to show you, we are in the Western Cape. On the bottom left there, we see there's a little arrow that's pointing north. So a normal map here with the scale and an arrow pointing north. Okay. All right. Lesedi, yeah, try and right click on the teacher screen and then unpin or log out of the meeting and then log back in and see if that helps. Right. Sometimes it does happen. Okay, let's get down to some standard scale questions with this map. All right. Now I'm going to have to move up and down. I will copy the questions as well to make it a little bit easier. But here's the first question. Calculate the real distance in meters from Fort Wynyard to the parking near the craft shop. Now, before we even look at the map, because I know what you guys are thinking, show me the map. I want to answer this. One thing I want to show you in this question, calculate the real distance. Okay, we have real distance, and then we have the map distance. All right. And I write it in the ratio like that because, well, in fact, I'm not going to give you too much information. Let's see what you know. But we have map distance and real distance in scale on maps. Okay, just reminding you about that. Okay, so what I'm going to do now is I'm going to copy this question and I'm going to bring it up here so you can see the map and also try the question. Now it says calculate the real distance in meters from Fort Wynyard to the parking near the craft shop. All right, now without a ruler, you guys might struggle with this. By the way, I don't know if you can see a mistake on this map. Jasmine's also struggling with black screen. Jasmine, try and right click on the teacher screen that you see there. Right click on it, unpin. That might sometimes help. Otherwise, log out of the meeting and then log back in. It sometimes helps. I don't know if you guys can see a mistake on this map. There is an error. Actually, pretty important that we pick that error up when dealing with this map. But I've got my ruler here to help you with this question. So who can tell me what I need to do here? I need to calculate the real distance in meters from Fort Wynyard to the parking near the craft shop. Who can tell me how you're going to do this? I need instruction. Anyone out there that can help me? So Fort Wynyard, I don't know if you can see on the map, is over here. And then the parking near the craft shop is over there. So that's that line over there that we need to work out the real distance. Anyone out there that can help me with this? Give me an idea of what I should do. Come on, where's my grade 10s and 11s? You guys should be screaming. Renewa, are you there? Check your screen. You should see it. There we go. Renewa, are you there?
Afternoon, sir.
Afternoon, how you doing?
I'm okay.
I'm good, thank you. All right, what should I do?
I think you should use your ruler and measure from point A to point B, and then multiply by the scales.
All right, so very good. Get your ruler out, sir, and put it down here on the map, and you can measure from point A to point D and see what it is. Now, before I do that, I'm going to come up here to my bar scale and put it there. What does that tell you?
It's 2 centimeters.
Let me move it down. What does it tell you if I move my ruler up to the linear scale or the bar scale there? Like that. How does that help me? If I move my ruler with some centimeters near my bar scale here, how does it help me work out the distance?
I'm not sure.
So you can see here, the bar goes from 0 meters to 200 meters. That's real world distance on the ground. And my ruler matches the 0. And for 200 meters, my ruler says?
1 centimeter.
1 centimeter. So 1 centimeter that I measure with my ruler on this map must give me 200 meters. Yes?
Oh, 200
Okay. Okay. All right. So I'm going to just write that down here. 1 centimeter. I can use a ratio, or I can just use an arrow to show that 1 centimeter must give me 200 meters. All right. Now I'm going to do what you said now, and I'm going to move the ruler down. How many centimeters is this line?
2.5 centimeters.
2.5. Okay, so what should I do now? What kind of calculation should I do?
2.5 times 200.
Very good. So I've got 2.5 centimeters. Each one is 200, so I'm going to multiply by 200 here. And we should all be able to get that. Right, so 2.5, let's get the calculator. It must work for me. I bought this thing. It's worked for me. All right, that gives us 500 meters. So when the question says, what is the real distance from Fort Wynyard to the craft shop? You can tell the person marking this exam, it is 500 meters. Renewa, thank you so much.
You're welcome.
Thank you for the help. I appreciate it. All right, there we go. Any questions? You guys must please raise your hands and we will try and answer any questions that you guys have. You should all be okay with what we're doing so far. Nothing strange here. Tando, my man.
How are you, sir?
I'm good. How are you?
I'm good. How are you? I'm good, sir.
What can
I
I do
want
for
to
you?
ask, how did you get? I want to ask, how did you get 2.5?
Okay, so when I move the ruler down here,
so when I move the ruler down here,
measure that line.
measure that line.
So we can see here
So we can see here
on my ruler 2.5
on my ruler
centimeters.
2.5 centimeters. Okay.
You got it.
You got it. Yes, sir.
Excellent. Thank you, Tando.
Excellent. Thank you, Tando. Thanks, sir.
My man. All right, there we go. Moving on to the next
All right,
question.
here we go. Moving on to the next question.
I can hear myself talking. And so, moving on to the next question. So, why did you leave the?
I think it's white.
Why did you leave the white part at the bar scale? All right. You mean this white part here? Bianca, is that what you mean? That white part on the bar scale? I'm sure that's what you mean. That white part of the bar scale. Yes, okay. So when you get a bar scale like this and you put your ruler up to it, And in fact, let me address this now. This is a bar scale, but it's also called a linear scale, line scale. And linear means going, in fact, remember we spoke about a linear relationship. As one increases, so the other increases. This bar scale or linear scale is wrong. Who can tell me what the mistake is? Before we explain this white part and why I didn't talk about it, who can tell me what the mistake is? Can you guys see an error in the bar scale? Can you guys see it? I know Kia can see it. Come on now, anyone out there? What's the mistake with this bar scale? Yes, that's right. When we talk about graph, linear is when the line goes up. It's not consistent. Very good. 100 is missing. Okay, Charles, yes, that's a good point. Klabo, yes, it's not consistent. Where's Klabo? I want to ask. He's got a good statement that he made there. Klabo, please come online and tell me why you say it's not consistent. What do you mean by that? Check your screen there. You should see a little option asking you to unmute. Talk to us. Tell us why you think it's not consistent. Yes.
Hi, sir.
Are you?
Good and you.
Good. What's wrong with it?
I think it's not consistent because it starts with 0, then it jumps to 200. So the next number should be 400.
Absolutely. This 300 shouldn't be there. That should be 400. Right? Because this space here, this little length here should match the one next to it. All right? They should be the same size. Okay? Those should be the same size. And if the first one goes up by 200, the second one should be going up by 200 as well. So that 300 is wrong. It's misleading. It's a mistake. They made a mistake there with this linear scale. It should be 400. So Bianca, 2 reasons. Number one, I wanted to ignore the white part because there's a mistake there. Yes, Charles, exactly. Not proper sequence, not consistent. I wanted to ignore the white part because that 300 shouldn't be there. Should be 400. And also, when you put your ruler up against the bar scale, you're trying to get an idea of what 1 centimeter will give you in the real world. So I don't know. I don't know what 2 centimeters gives me. I only want to know what 1 centimeter gives me. So 1 centimeter represents 200 meters here. So 1 is to something. So when you write ratio scales and maps, they always start with 1 is to something. And that could be useful later on because if they would ask us to actually create a ratio scale here, we're going to use 1 and not 2 because I want 1 is to something. So that's why I wrote this over here as well. It's like a little statement here saying that 1 centimeter on my ruler gives me 200 meters on the map. Okay, I hope that explains why I ignored that Y part. 2 reasons there. All right, let's have a look at the next question. We're getting a little bit more challenging as we go now. You guys know me. As we go deeper in, all right, it gets darker. All right, I shouldn't really say that because it scares people, but you know what I mean. As you go deeper in the pool, the water gets colder. All right, it's not as comfortable. Okay, so question B says, given that the real width of the Duncan dock is 0.5 kilometers, determine the map width of the dock. All right, let me take this question. And I'm going to put it here. Let's move this one. Here it is. Given that the real width, there's that word again, real width of the Duncan dock, which is this line here, or there's the dock. So that's the width they're talking about on the map. Given that the real width of that is 0.5 kilometers, determine the map width. So we're going from real world down to map measurement with ruler, from real world to ruler in this question. The first question was measure with the ruler and tell me what the distance is in the real world. This question says, this is the real world length or distance. Tell me what is the map ruler measurement? How long is this black arrow on the map in centimeters? Okay. All right. Who can tell me what we're going to do here? Anybody out there that can help me out here? I'm going to bring back this relationship again because that's important. If I write that, I'm sure someone's going to be like, ah, I know what to do. What do we do here, ladies and gentlemen? Convert the kilometers to meters. All right, very good, Jasmine. First thing we do is take the 0.5 kilometers and convert it to meters. So we times by 1,000, and we're going to get 500 meters. Now, why did Jasmine suggest that? I think it's because there are meters in this relationship, but my question gives me kilometers. So we want to work in the same units. All right. So now we've changed it to meters, which is good. All right. And now Fifi saying, or screaming, divide, divide, divide. Yes, because if I know that every 200 meters is 1 centimeter, in my 500, how many 200s do I have? To work that out, I will need to divide. So I've cut my 500 meters up into 200 meter pieces because every single one of those 200 meter pieces is a centimeter. So I'm going to divide, and you should all know that we're going to get 2,5. And what are the units here? Centimeters. All right. So we're using this relationship that we saw come off the bar scale, using that relationship that we got off the bar scale to help us solve this. All right. Very good, Fifi. Yes. Any questions? Are we all good? Yes, Tando. All right, Tando, check your screen there. Just try put your speaker down, Tando, when you...
Say, I was saying you must go up because I only see question A.
Oh, okay. Well, we've done. You want to see A that we did before this? You want to see A that we did before this?
Yes.
Oh my gosh, I erased it. I'm so sorry.
No problem, sir.
All right, I'll try to repeat it at the end of work time.
Okay, sir.
All right, moving on to the next question. I hope you guys are okay with question B. Let's move on to the next one. Another common scale question that comes up here. Let's see if I can't copy this back so that we don't lose it. All right, let's go check what the next one is. Let's put that there. Yes, the next question, it's question C. All right, I'm going to put it up here for us. I'm going to move my ruler out the way. Don't need that. So it says, yeah, given that the real distance from the Two Oceans Aquarium to the clock tower, which is this line here, and that I'm pointing to in red, if that real distance is 400 meters, show that the ratio scale of the map is 1:2000. Okay, so we got to use the real distance here. All right. And how do we work this out? For this ratio here, look, we need two things. All right. We need to create this ratio and prove the ratio is 1:20,000. Now there's two parts to this ratio. I'm going to highlight in yellow. Instead of writing the words, highlight in yellow there. The yellow part is the real world measurement. The yellow part is the map measurement. The green part is the real world measurement. So our ratio needs two parts. The question gives us a real world measurement. So to create this ratio, how do I get the yellow part? What should I do? Anyone out there can give me a recommendation? Actual distance times scale factor. Okay, yes. Okay, Bianca, use that. What is the scale factor though? What is the factor we need to multiply by? Or do we need to multiply it? Anyone out there can tell me, how do I need two parts. I need a real world distance, and the yellow is a measurement distance. Okay, scale factor is 2000. All right, so guys are screaming at me, sir, scale factor is 2000. Okay, all right, I'm going to show you another way to do it here too. I'll give you a suggestion here. So if I measured this line, and it looks like it's going to be 2 centimeters, let's call it 2 centimeters there. All right. So if you measure that line and it works out to be 2 centimeters, then you can start building the ratio straight away. You can say, I've got a map measured 2 centimeters, which the question says must represent 400 meters. All right. I'm going to highlight again. The 2 centimeters is measured. The 400 meters is a real distance that they gave me in the question. Okay. Now, I need to convert this to the ratio that they see there. So what I'm going to do is first change the 2 to a 1. All right. To change 2 to 1, I'm going to divide by 2. But what I do on the left side of this ratio, I must do on the right side of this ratio. So now I'm going to get 1 centimeter is to 200 meters. But this is not the correct way to write a ratio scale for a map. A number ratio scale in a map always must have the same units. Always, always, always. And I can see there's going to be a mistake here. Yeah, it shouldn't be 20,000. No, it's right. That's fine. All right. So the number ratio scale here should always have the same units. We need centimeters on the left and centimeters on the right. So like people are saying to me, we need to change our meters into centimeters. How do we change meters into centimeters? Everyone should know. Manati, very good question. You see this line here at the bottom on my map. This is what the question is talking about. They say the Two Oceans Aquarium, which is here, and the clock tower, which is here, that line between them, that distance, I'm telling you that if I measured it with my ruler, you would get 2 centimeters with the ruler. Unfortunately, I can't adjust my ruler at an angle on the screen. So I'm just letting you know it is 2 centimeters, okay? You got to pretend that you measured it with a ruler and it was 2 centimeters. All right, to get meters into centimeters, Aibo, guys, we got to times by 100. All right, we got to times by 100. Sorry, we don't need to do it on the left. We just need to do it on the right-hand side. So we got 1 centimeter here is 2. 1, 2, 3, 4. Let's check with the calculator. Let it do the work for us. 200 meters times by 100. Oh, 20,000. Yes. Okay. So yes, based on the information they give us 2 things. Well, they give us one, we've got to measure the other. They gave us that the real world distance is 400 meters, and they tell us that it's that line there on the map. So you measure that line and you get 2 centimeters. This is measured. So I'm going to write a little word here. Measured. And this one was given in the question. All right. So we should get 20,000. 1 centimeter is equal to 20,000 centimeters. So we're confirming the question's ratio scale because they say show that. Look at this question here. They say show that the ratio is 1 is to 20,000. All right, and we've showed we've got that exact ratio scale there. So often they ask you to build a ratio using this method. Just remember, the ratio always has 2 parts: a map measured part and a real world part. So you start with a statement like this. All right, you start with a statement that I've drawn over here. A real world measurement on the right and a map measurement on the left. And from there, you change and simplify your ratio to get, you first want to get 1 on the left, and then you want to get the same units. The aim is to get the same units here. All right, so you have to end off with the same units. A 1 on the left and the same units as well. Those are the 2 things you must do. Get a 1 on the left and the same units. Are we all good? Are we ready to take a break? Are we ready for a break? It's break time. Oh, sorry, Sapiso. Usually Thursdays is bad for me. Fifi's, I guess. I need a break. All right. Here's a question. Is anyone in the Western Cape or in Cape Town? Bianca. Is anyone in the Western Cape or in Cape Town? Because I'm hearing some stuff coming out of that part of the world. And I'm in Durban, I'm very far away. Charles, how hectic is it? Is it bad? Charles says is it bad there? I'm interested to know because I'm hearing stuff on the news. You see stuff on social media. You don't know if it's true or not, and it sounds and looks hectic. Because Durban had something similar, or we didn't have. Yeah, me too, Fifi. It's horrible. We had stuff happen in Durban. So we had stuff happen in Durban. So careful. Just as a matter of interest, the bit of a battle, but it's not that bad when I say battle. The municipality of Cape Town is refusing to back down against the taxi association, and there's a taxi strike. Sure, couldn't go to school since Friday. And yeah, it's not pretty there. I'm seeing some stuff that's not very pretty. I hope it gets sorted out very quickly and you guys can back to normal schooling. But just spare a thought for all those people in Cape Town. Our thoughts are with you. We hope they get sorted out quickly and we can all get back to studying, because that's the reason for we all here at the moment is to learn. We don't need this nonsense to distract us from what we really want to do. But we're going to be here. Watobe's here. We are online, so we don't have to worry about location. So we're here for you guys. Okay. Don't worry about location and transport for us here. It's one of the benefits of being in an online class. All right. For some of you, do you remember COVID and online? Oh, yay. All right. So,
Hi,
yes.
sir.
How you doing?
I'm doing good, sir. May you please go back up to like the previous question?
Question
Yes, sir.
C.
Yes.
Yes. What can I do?
Oh, I just wanna take notes.
Sure. No problem. At any time, guys, if
Okay,
you want to
thank
take
you.
if you want to take a screenshot, please let us know and we can stop and let you guys take screenshots.
Okay, thank you, sir. I took a screenshot.
Awesome. All right, let's continue. Spirit thought for all those people in Cape Town tonight, eh? Hopefully it gets sorted out. Our thoughts are with you. All right, we're moving on to this part of the question now. All right, so this is based on the same map as well. This is contextual. So there's obviously a story involved here. This is contextual questions based on this map. So it says here, Stephanie and her family from Australia are planning to visit to Cape Town. They'll be, I wouldn't go now. They will be visiting the Victoria and Alfred waterfront during their time there. Annex A, which is the map, shows a map of Victoria and Alfred waterfront. Use the map in Annex A to answer the following questions. All right, here we go. What type of scale is used in the map? You guys already told me. Bar scale. I'll give you another word here, or linear scale. But bar scale is the preferred answer. Yep, we got that. Good. Now it says 1.2, identify the activity offered at East Pier Road. Identify the activity offered at East Pier Road. So I'm going to go up to the map, and you guys can type in chat there. What is the activity at East Pier Road? One of you guys can see it. What is the activity at East Pier Road? All right. Yes, very good. Helicopter flights. So this is what they were looking at here. Helicopter flights. This is East Pier Road. And the little star there shows the activity. Very good. And when you see the, yes, very good, Chipang. When you see these questions, you are very happy because it's not much work for 2 marks. All right, we don't have questions in math literacy. Yes, you guys are absolutely right. Helicopter flight. And I know what you're thinking. This is way too easy. Hold on, guys. You know me. The good stuff is coming. All right, next question, 1.3. At which attraction site would a person be if they were to follow the directions below? Now, it's important that I discuss this. I want to bring it up to the map, and we're going to put it here. And I need to say, hold on a second. I'm going to have to delete this. All right, let's delete the other question. Oh, there we go. All right, there it is. At which attraction site could a person be if they were to follow the following directions? All right. Now, I need you to pay attention to what they've written here, because often in the map work section, they ask a question which is, a person is at one point and they want to get to a different place on the map. Give directions to get from point A to point B on the map and write them out. Okay, this is what it should look like. So this is a very good way for us to see how to answer that type of question. They're saying, at which site would a person be if they were to follow these directions? This is how you should be writing directions if you got a question like that. Give directions from point A to point B. Okay, so as we go through this, look at the words they use. I will highlight them, and you should try and use the same words when you answer this kind of question. So we merge onto Dock Road from the N1. Where's the N1? Here's the N1. All right. We merge onto Dock Road from the N1. Dock Road, Dock Road, Dock Road. Guys, I can't see Dock Road. Can you see Dock Road? Let's look at the next one. Maybe they'll give us a clue. Take the first exit at the Dock Road roundabout. They must have left it off. So I think this here, this road here, I'll highlight it for you. Is Dock Road. Okay, because the instruction says merge onto Dock Road from the N1. Now the N1 is these two gray bars here at the bottom right hand side, and we're merging onto Dock Road from the N1. In fact, I would put it a little bit further up. Okay, so I'll put it here. Sounds like someone knows the area. Okay, Southbound Road. Yeah, it looks like Southbound Road there. So you see how the N1 merges into Dock Road? Okay, so I think this road here that the N1 ends at is Dock Road. Okay, so when this N1 merges, it joins up with. All right, so I think that's this road over here that the N1 is connecting to. And then they say, take the first exit at the Dock Road roundabout. So there is a roundabout here, okay? And they say take the first exit. Now the first exit, if you're traveling and you're going left, always in a roundabout, go clockwise like this, then the first exit you will take is this one here. All right, so I think that's where we're going, okay? But look at the words that they use. They use words like merge and first exit, all right? Just try and remember how they explain these directions. Then it says continue onto Dock Road and join Western Boulevard on your left. Jonas, where's Western Boulevard? There's not even any words here, guys. These people are not fair, man. Let's carry on. Turn right onto Portswood Road. Oh, turn left onto Beach Road. Sure, these guys are not fair. There should be road names. But I think we need to continue on this road. And then we join another road over here. All right, the roads join up. It says join Western Boulevard on your left. So this is probably Western Boulevard. Continue straight on Western Boulevard. Or the M6. Oh, there it is there. There's the M6. There's the M6 there. Turn right into Portsmouth. Oh, so it must be going this way. Turn left into Beach Road. All right, so I think this is what they're talking about, guys. Without road names is a little bit different, difficult. So, but I think this is what they're talking about, ending up at Fort Windward. All right. But the main thing I want you guys to notice here is the words that they use to describe the directions. Okay. Remember these words. All right. So those are the kind of words that you will use when you give directions. Yeah. Maybe it's Little Table Mountain. If I take Beach Road over here, maybe it becomes Little Table Mountain, or maybe Granger Bay. Right, where we end up is not very important here. Without road names, we can't actually be exact. There should be road names here for us to follow. So it's either Little Table Mountain, Granger Bay, or Fort Windward that we need to be on. All right, where we're in this area here. But what I wanted you guys to see were the words they use to help with directions, because they're going to give you a question, they often do, where they say, the person needs to go from point A to point B, write directions for that person, how to get from point A to point B. And these are the kind of words that we use. So continue, turning right, turning left, merging, first exit, second exit. You can also, remember this, mention sites or places that you pass. Okay, so mention sites or places that you pass. So you could say you're passing the aquarium on the right, or you're passing a church on the left. Go past the church on the left. Go past this on the right. And that'll help the person understand exactly where they are. So use these words and mention places that you're going past or that you can see. Okay, you will see the coffee shop. You must turn right before the coffee shop, or you're passing the coffee shop. Words like that. Okay, so I wanted to just show you this to you guys so you can see what words to use if you have to describe directions in a question. All right, but let's get down to the meat, the dark waters of this question here tonight. Have a look here. I'm going to zoom out a tiny bit. All right, so it says here, Stephanie's family planned to drive to Cape Town from Durban and found the information below on Google Maps, as you do. So it shows there from Durban to Cape Town, and then at the bottom here, we have some information. We got two things. We have a time and we have a distance. Yes, the sites are the ones with stars. And you know what they're going to ask. If they give you a distance and they give you a time, they're going to ask you for speed. All right, there it is underneath there. It says, determine the average speed of this journey to the nearest kilometer per hour. So we have to round off to the nearest kilometer per hour. You can use the following formula. Now, I don't know, and Kia will remember this. If you guys remember the first measurement, the grade 11s will remember, the first measurement course we ever did, we had a question like this. Yo, that's when emojis, Chiamo's emojis first started, Kia. That speed, distance, and time question. That's when Tiamo start using emojis. But let's have a look. How are we going to do this? Who can tell me? Maybe Tiamo or Bianca must help me with this one. How do we work out the speed here? They tell us speed equals distance over time. We need a distance and we need a time. There we go.
Yes, Bianca, I
There we
believe in you.
There, ma'am.
Bianca, there we go. Such a
Hi,
familiar.
sir.
Good. Bianca, you remember these questions?
Yes, sir.
I remember when we first did one of these. Phew. All right, what do I do? Do I just throw it into the formula?
You need to. I think you need to convert. Is it? Don't you need to divide the distance over time?
We can throw it into the formula. We've got kilometers and we've got hours and minutes, so we could get an answer. But there's one thing that I mentioned to you guys that you got to remember with these questions. Can you remember that thing? One thing you got to be careful of with these questions. It's got to do with the time. If you look at the time here, I'll write it out for you. It's 17 hours and 23 minutes. What's the problem with this?
Oh, the decimal hours and
Yes.
the hours and the minutes.
Yes, you remember that?
Yes, sir.
All right. How do you think we could change the 23 minutes into decimal hours?
You need to divide 17, 17 divided by 60 to get the hours.
Yes, you're right. We do need to divide by 60. We need to take these minutes and divide by 60. Let's do it here quickly. So 23 divided by 60. 23 minutes is 0.38 of an hour. Now, stay with me, Bianca. I just want to show you guys something. What if we had 30 minutes and we divided by 60? That would give us half an hour. What if we had 15 minutes? 15 divided by 60 gives us a quarter of an hour. All right. So it does make sense, but we got 23 minutes. So we're going to get a horrible looking decimal. I'm going to say here 0.38. I'm going to round off. You okay with that? I'm going to say 17 hours plus 0.38 of an hour. You happy with that, Bianca?
Yes, sir.
All right, excellent. Now what do I do?
Now you need to, okay. You need to divide the distance over the time.
Very good. So there's my distance. And here's my time, 17.38 hours. All right, ladies and gentlemen, if you put in kilometers and hours into this formula, it will give you kilometers per hour out. If you put in meters and hours into this formula, don't expect kilometers and hours out. Whatever you put in here, you will get out. But like Bianca remembered, we have to change the hours and minutes format into decimal hours for this formula. This formula only takes decimal hours. Okay, now I'm going to move all this stuff down and we're going to see exactly what speed these people were traveling. I'm sure you guys are already writing answers on the screen there. The calculators are working. Okay. All right, let's check it out. So I'm going to move my calculator over a little bit. There we go. So we're going to say 1626. Bianca, have you done it as well?
Sir?
Have you done it on your calculator? I want to compare answers with you.
Oh. I got 93.5. I don't know.
Yeah, that's right. So 93.55, but we're going to round off the second decimal. So what should it become? Ninety-three comma 56 kilometers per hour.
93.56.
Excellent, Bianca. Excellent.
Thank you, sir.
All right, Bianca. Shame on you. Thanks for the help. I appreciate it. All right. Any questions about this? Any questions? Are you all understanding it? Does it make sense? Please remember this. I'm going to write some notes here. Okay. I'm going to erase the D part here because we don't actually need this. All right. Let's make some notes here about this. I'm going to make some space. And let's make some notes here. This formula here, number one, only takes time in decimal format. All right, number one. Because the speed is a decimal, we are going to round it off to 2 decimal places because that'll be the main instruction in the exam. We're not going to round it off to, oh, I see what you're saying. the question the instruction in the exam, I'll finish my sentence. The instruction in the exam is to round off to 2 decimal places unless told otherwise. And someone's reminding me, it's telling you otherwise. Round off to the nearest kilometer. So let's go back to our 93.555, round off to the nearest kilometer. We go up to 94. Yep, I didn't even read that instruction properly. You see what happens? All right. Read the instruction carefully. Highlight it like that, then you remember. All right. The second thing you need to note down for this formula is, besides the fact that it only takes decimal time in decimal format, is that the units you get out are the units you put in. All right. The units you put in are what you're going to get out. Okay, so if you put in kilometers and hours, you're going to get out kilometers per hour. So if the question wants kilometers per hour, change your units to make sure that you've got kilometers and hours before you go into the formula. Because if you do it, if you put the wrong units into the formula first, you're going to have to change it after. And sometimes that's a little bit more challenging. Change the units first and then put them into the formula. It's the best way to do it. Okay. So 2 things, only take decimal format for time, and the units you get out are the units you put in. All right, please remember that. Thank you, Safiso, for reminding me that we need to round off to the nearest kilometer. The nearest kilometer. So that must go up, right? So this 3, we're looking at the 3 now, and the nearest kilometer, whole kilometer, depends on the 5 next to it. That's a 5, so we got to go up to 94. All right,